Good morning. Thank you for the introduction. And it's a pleasure to be in wonderful Spain, in wonderful Madrid. I always love to visit here. And thank you, Fundación Ramón Areces, for organizing this. So what I'm going to do in the next, 30, 40 minutes, I'll put some foundations to make sure that we are on the same page in order to understand what are the challenges which are ahead of us. And when I'm saying ahead of us, it means all of us, me and you and your companies, governments, policymakers, industries. You will see that if we really want to reach the targets which we have stated, we need the inclusion of all of us. And why is that? Well, we already experienced, so somebody already mentioned the dust from Sahara. Well, you already see that we are experiencing more and more extreme events. So what does it mean? It's not just global warming. It's more of extreme events which all of us are going to experience. Well, we will see much colder winters. Even though it's going to be global warming, we will see at some point it's actually going to be a stretch of very cold weather. We will see extreme events in terms of the flooding. We will see extreme events in terms of droughts. So in my talk, I'm not going to go and persuade you that all of these are here to stay. And all of these events are here to stay for the rest of our lives. And we would need to learn how to deal with that. And we need to do our contribution that our children, our grandchildren, actually will have a better planet, that we are not going to destroy the planet for them. And these are very important words, but we have to save the planet. And that's not an exaggeration. So again, I'm not going to get into all the detail of the physics behind that. We have a lot of climate scientists who are showing us all these negative impacts, which we are going to have even if we are going to stabilize, because the temperature is going to rise, ice sheets are going to melt, sea level is going to rise even with stabilization scenarios. So, at the same time, if we want to decarbonize, we will have to do a lot. And usually I like to start with this picture, and hopefully you can see at least some text around that picture, which shows what the contribution from different sectors of the economy to the total greenhouse gas emissions. And so you can take a look your sector, which you're representing, or you can take a look closer what we can do if we decarbonize some particular sector. There are several important messages which one can deduce from this particular diagram. Well, most of you probably have heard that, the solution is to electrify and to decarbonize the electricity. Well, you also have heard probably that, the solution is to electrify cars, electrify private transportation. So this diagram actually can show you that, take a look at that road transport. And so about half of that is a private transportation. So we can electrify all cars, while that is going to be only a small share of the emissions which we have to reduce. Well, and even electrifying all cars everywhere in the world, that's a quite challenging task. So that gives you at least some understanding about the scale of the challenge which we are facing. But you also can see that it's not only about energy. So energy is an important part, it's an important contribution, but there are other parts which we also have to deal with. And what's the point of here? If we are really talking about net zero goals, we have to eliminate all of these. So look at all of these activities. In order to reach climate stabilization goals, we have to eliminate all of these. And as you can imagine, that's a quite substantial challenge. That's quite an aggressive actions which we have ahead of us. But if it's a challenge, it means that you have an opportunity. So it means that no matter how small your contribution to this pie, it's still important, because even that small contribution has to be reduced to zero. So there is no excuse of saying, oh, our industry is so small, it's not really contributing that much. That's not really the right way of thinking. You have to reduce emissions from every activity. And so, well, again, if you are making strategic plans, if you are making a visionary, if you are trying to understand where you are going with your business, well, you'd better look at those opportunities, how to reduce those emissions. And this diagram is just a reminder from Intergovernmental Panel on Climate Change, so IPCC. They have issued a report about 4 years ago. What are the trajectories in terms of the emissions which are needed to reach 1.5? And why I'm bringing these diagrams? Well, two messages here. Well, one, we don't really know the exact trajectory, but we know for sure that by mid-century, if we want to reach those goals, we need to drastically reduce global emissions. And then there is a story with BECCS, which is bioenergy with carbon capture, or AFLOU, agriculture, forestry, and land use. So maybe we even need negative emissions. And in the Q&A period, I'll be happy to expand. We have done several studies where we are trying to understand what is the scope for these negative emissions. Because some sectors are going to be very hard to decarbonize. And we might need these offsets in order to compensate for the emissions from the sectors which still are going to have positive emissions. What's the point here is that when you are doing that, historically, we have never done that consistently in terms of the emission reduction. So what I'm showing here, those are the historic emissions from 1965 from fossil fuels. And you can see that, well, yeah, we had couple of the experiences where emissions went down. I don't think those are, well, pleasant experiences because, well, global financial crisis brought the global emissions by 2%, but I don't think that's a solution to climate change. We should have much better tools. And the pandemic brought the emissions by about 6%. And International Energy Agency, a couple days ago, issued the report where they assessed what were the emissions in 2021, and actually emissions in 2021 are highest ever. So we came back, we even overshoot, even though the pandemic is not over, even though we still have some restrictions in certain activities, in terms of the emissions, we are actually increasing them. So that's actually a movement in the wrong direction in comparison where we need to go. So again, it's a lot of actions, it's a lot of activities, and Spain is one of the countries which we usually use as example of bringing low-carbon energy. And so even here in Spain, it's still a lot of challenges, it's still a lot of actions which are needed both from the industry, policymakers, and customers in order to reach those particular targets. Another diagram which is very useful to illustrate what is the perception versus what is the reality. So this diagram shows you a couple of the trajectories, so 4 different trajectories. And the top one is the trajectory which is assessed by International Energy Agency. They went and tried to analyze sector by sector, country by country, what are the current legislations, what are the current regulations. And based on that, they were trying to understand if we will be at that level of regulations, what would be the emissions? So you can imagine that without those regulations, the emissions would continue growing. But those regulations are only stabilizing the emissions. So you can also see that trajectory which is needed for decarbonization. And International Energy Agency, well, there is a word energy, they care only about energy emissions. So in this diagram, actually, I'm not showing you the agricultural or other emissions which are also needed to decarbonize. But even in this trajectory, if you're going to take a look at 2030, which is only 8 years away, and you can do a vertical line in 2030 and take a look at the gap between where we need to be in 2030 and the pledges which were announced at COP, at the recent COP in Glasgow. So these are all the promises which countries are making. So it means that, well, we are not really sure that we are going to reach those promises, but, well, that's at least what the countries are making a promise. Like the United States is promising that we are going to reduce emissions by 50 to 52%. We don't really have a good regulation or legislation how to do that, but at least that's a promise which we have made. Similarly, different countries have made different pledges, different promises. So if you're going to take a look at that difference between what countries are promising, not on the books, not in terms of legislation, but in terms of promises, and compare where we need to be in 2030, only 8 years away, that difference is about 12 gigatons of CO2. 12 gigatons of CO2, that's bigger than emissions from China. So it means that, well, we actually need to make much more aggressive actions if we're really serious about net zero, if we're really serious about stabilizing climate. And if not, well, we will experience those extreme events which I have described initially much more. And unfortunately, that also means financial risk, both on the physical side and transition side for every company, every industry. And it means that you actually need to take consideration, you need to quantify what are the physical risks to your infrastructure, but also what are the transition risks to your infrastructure. Because we don't really know which trajectory we are going to end up with, and I'll show you a couple of the examples how to read this from the company statements. This diagram provides you an illustration that currently we don't really have one answer to decarbonization puzzle. So you can see that here we are listing many things. So this is again from the International Energy Agency, the graph that shows different components. And you can see that because economic growth or population growth, the magnitude of the emission reduction is actually growing over time. And currently we are at about 35. So by 2050, actually we are going to decarbonize much bigger pie because we are growing. India is growing, China is growing, Africa is growing. Many regions are going to grow and demand more energy. And yeah, indeed, electrification is an important part, but there are many other sectors of the economy where, well, we cannot really electrify everything. And so to the best part, well, what we know, electrification is good trajectory. So wind and solar is a good trajectory, but that's not enough. Another point, you have to be careful with these wedges. So like if you're looking, how much is going to be in CCS and industry versus how much is going to be in hydrogen, it's a lot of interdependencies in this picture. So don't take that as granted that this is what is going to happen. This is just a scenario. And that's an important part to stress because we are working a lot with investment community. So we are working a lot with banks. We are working a lot with investment management companies. And well, whenever we talk to them, they are all familiar with this net zero report, and they think that this is where the world is going. So as simple as that. So they are not really dialed into the reality which I showed you, but they're thinking, oh, this is what is going to happen, and this is the trajectory. And well, we work a lot with IEA, and our colleagues from IEA are telling us, no, this is just a scenario. Don't take that as, well, this is exactly what has to happen. But in many cases, that's how it is interpreted. And sometimes it is interpreted in such a way that I know several cases where big companies are sued. There is legal action against companies based on this particular figure. And those legal cases literally saying, well, IEA told us you have to do this, you're not doing this, we are bringing legal action against your company. And I'm not going to name those big companies, but you can take a look, and there are several legal cases which are based on this. But this is just a scenario. That's not the one unique trajectory which we are going to reach the target. And you can read some of them, and I'll leave it up to you to make your mind how realistic some of these targets, and even if you're looking at the historic targets, what we need to do, well, we haven't done that. So what does it mean? So again, there are a lot of uncertainty where the world is going, where the energy system is going, where the society is going with all these targets. This point also illustrates you that, well, these scenarios, you have to be, again, very, very careful in interpreting them. So this diagram provides you some changes in the attitudes of these projecting agencies. And so we are also doing our own projections and trying to understand what would be the energy mix in particular region, particular country, in particular sector. This diagram provides you the comparison of the thinking of IEA, International Energy Agency, in comparison to all these big models, integrated assessment models. We have one of them at MIT, which were used for IPCC reports. Well, one thing to note in that text, it's a busy text, but it's a very important condition, very important explanation which is hidden there. What they are saying that there are 90 scenarios in that IPCC report, 90. Many of them cannot reach net zero by 2050. Even in the model, not in the reality. Reality is much more complicated. But even the models say that's a very challenging task. And out of those 18 which were able to reach, well, you can see where the thinking of IEA against those models. And again, one thing which stands out is hydrogen. And I'll provide a couple of the examples about hydrogen. And I'm pretty sure all of you have heard about hydrogen as a solution, especially green hydrogen. And you can see that in this particular case, IEA has changed their main thinking. So if you're familiar with the World Energy Outlooks from IEA, usually they are middle of the road in terms of hydrogen and carbon capture. So that's CCUS, carbon capture, utilization, and storage. Well, they have changed their stance against that. I'll provide some of the explanation why that is happening and what is the story about the hydrogen. Another point which we can kind of take a closer look whenever we are talking again with not the energy specialists because they know this, but again with policymakers, with investment communities, they have in their mind that okay, by mid-century, oil is going to disappear. Natural gas is going to disappear from the energy mix. Well, I just told you that even in the most aggressive scenarios where we are not sure if we are going to be in that aggressive scenario, so that low line is NZE, net zero emission scenario. So even in that very, very aggressive scenario, we are still not at zero. We are still using oil and gas. So again, there are many misperceptions in the public against what is the reasonable approach, what is the reasonable trajectory for the energy of the future. These percentages are actually very helpful in order to understand what companies are thinking, where they are, because I would argue that it's not about technologies. Decarbonization, well, we have a lot of technologies. It's not about the economics. We know how to bring those technologies, but rather it's about the policies and public acceptance and realizing how much are we willing to pay for decarbonization. And again, take a look at that 20% for NZE, net zero emission in 2030, well, 2% for sustainable development scenario. And you can compare that with the statements from some major oil and gas companies. So, for example, Shell has announced that by 2030, they are going to reduce oil production from Shell company by 18%. So, well, you can immediately deduce what are they thinking, where the world is going to be in 2030, at least in their perception, where they're going to be against the reality. If you're going to take a look at the statement from BP, they are saying that they are going to reduce oil and gas production in 2030, only 8 years from now, by 40%, 40. So again, that sends some clear message, what is the thinking from the major energy companies. At the same time, if you are going to take a look at the numbers which Shell is saying in terms of the electricity production, the target for 2030 is 530 terawatt hours that they are planning to sell. 530 terawatt hours, that's about electricity consumption of Spain, or that's about the electricity consumption of Germany. So Shell can power the whole Spain if they will decide that they will sell all that electricity in one particular company. So again, that provides you the thinking where most likely we are going to go in terms of the investment, in terms of the decision making. Here I'm providing you some of the tools which we use. So at MIT we have a lot of tools, and again we are looking a lot at energy mixes, but it's not only about the energy, it's not only about the policy, it's about the impacts, about the trying to understand what are the risks, how do you assess how things are going to affect your company, what are the environmental consequences, what are the water availability, what are the land implications of different decisions. And so we are doing a lot of this, and well, obviously I wouldn't have time to go in detail for there, but well, feel free to contact me and I'll be more than happy to describe that, because this is how we interact with companies. So we have a lot of companies with whom we are working and try to help them with their investment decisions, the scenario analysis, the strategies, and we are trying to quantify what are their physical risks and what are their transition risks, right? And so I just told you that, well, if we do nothing, if we slow the decarbonization, it means that the physical risks are going to be higher and higher. But if we do decarbonization, well, then we need to take into consideration those transition risks very, very seriously. And that's exactly what we do when we are trying to understand what is the portfolio, what is the impact on the investment portfolio, what is the impact on the assets when you're doing different things. And that diagram on the right shows you that there are many policy instruments which one can use, and depending on which policy instruments you are using, the cost for the society will be different. So it means that Spain may pay twice as much if you choose not so wise policy, and it means that every citizen is going to be impacted much more than they should. So it's a lot of things which is going to be dictated how exactly you're going to approach the decarbonization paths. Well, this diagram just, again, to this slide shows you that we are trying to understand all things in many sectors of the economy. And again, MIT has a lot of centers which look at different components. Well, at least what we do at the joint program, we are trying to understand what are the implications of these different choices. And all this in the public domain in peer-reviewed literature. So you can see that we go all the way from agriculture to carbon capture to electrification. And we also do something which is called Global Change Outlook. That's a publicly available, very readable, or at least that's what's the intent, very readable to general public. So go to Global Change MIT-EDU, it's publicly available, and you actually can take a look at visualization tool. You can see what are our results for temperature, for emissions, for energy mix. And we have Excel tables for 18 different regions of the world, which you can download and take a look at in different scenarios. What are the energy mixes? What are the emissions? What are the electricity mixes? From our projections, how we see where the world is going. And, well, these are just a couple of the snapshots, well, in terms of the global primary energy, but again, we have a lot of information at the regional level. And you can see a lot of that dark color on the top. So, again, these are global pictures. So it means that some regions actually have to decarbonize or remove that coal from the bottom much more aggressively or push renewables much more aggressively, which on the top. And you can see the picture on electrification. I told you that story of electrifying, increasing electrification. And again, we are confirming that in our best view, we will see a lot of low carbon by mid-century. But again, that's not really enough because we also need to decarbonize industry, and that's a much more difficult. And again, we are doing a lot of assessments. What would it take to decarbonize iron and steel? What would it take to decarbonize cement industry? What would it take to decarbonize shipping and aviation, where electrification is not really the answer, at least right now? So again, there are many challenges, but that means that there are many opportunities. And we do a lot of things and individual projects where we try to look at different components. And you can see that, well, nuclear fusion is one of them, and you're going to hear in the next talk what we are doing at MIT in terms of the nuclear fusion. But there are different components, and the answers most likely are going to be very different in different parts of the economic system. And that means it's a lot of opportunity. So that means even if you are going to solve 1% of the problem or 5% of the problem, that's still a very important contribution. Obviously, the bigger the answer in terms of the contribution to the global emissions, better. But again, just don't think that if something which you're working or implementing or reducing emissions from your particular company is not really important. No, it is important because all of the emissions have to go to zero, and we need to have solutions for that. So, well, this is the slide. Whenever I give the talk, everybody expects, oh, if you're from MIT, you need to tell some nice stories. Okay, well, you just told us how difficult it's going to be. Well, we know how difficult, and so, well, that's great. Well, tell us something bright. So here is my story about the bright. So if you go back to your companies and you will tell, oh, well, I had this presentation from MIT, and he told us, well, that we need to work much harder. You need to work much harder, but there is hope. There is a hope, and we are hoping that we are going to provide the answers. Again, I'm going to skip that diagram. I see that Dennis is looking at me suspiciously. Am I going to represent the fusion correctly or not? So I'll skip that for the next talk. But that diagram on the right, well, that's a nuclear battery. So that's another thing which we are trying to develop at MIT as a concept. So while nuclear might be a very important part of the solution, we just need to make sure that we are addressing safety and economics of nuclear. And so that approach actually is trying to do both of that. So what is nuclear battery? If you are going to take a look at the usual size of the nuclear reactor, which are currently commercial, so it's about 1 gigawatt, right? So 1,000 megawatts. So if we are talking about small modular reactors where we are trying to do the economy of scale, which will be produced at industrial scale, well, the size of those is about 100 to 300 megawatts. So at least that's the current thinking. Well, this nuclear battery is much smaller. It's about 10 megawatts. But what's the beauty of that? Well, it's of the size of the shipping container. So you literally can fit that into shipping container. You can bring it wherever you want. This thing is produced at the industrial facility, or at least that's the current thinking, that you are going to save a lot of money not by building very expensive nuclear plants somewhere and bring a lot of engineers and workers, but you will build that at the industrial facility, bring it where their energy demand is, and after 10 to 15 years, you ship it back to industrial facility. So, great solution. So hopefully that might be part of the answer. Well, this diagram on the bottom, yet another example what different things might affect very basic way of doing business currently. So that diagram down below illustrates at least the idea, the concept that you actually can use carbon blacks and nanostructures to replace cement, to replace construction materials. So I just told you that decarbonization of cement is a very challenging task. It's because it's not only about energy, it's about the process. So you actually can do, let's say, methane pyrolysis. You can produce your hydrogen, and as a byproduct, you can produce carbon blacks, which you can use in the construction materials. And that's a huge market. And so the economics is very, very different. Or even better, you can use it as a storage. So think of the building, and that's a battery. Well, sounds like a fantasy land, but actually that's what a lot of researchers, well, at least several researchers at MIT are working currently. So we need more and more of those type of the activities, those type of the answers. For the sake of time, how am I doing on time? So I'll skip this diagram just to show that you have to be careful with projections, even with the most aggressive projections. I just told you that IEA is very bullish on hydrogen, but even then you can see that it's about 3% of global industrial energy consumption. Well, you need to add ammonia, synthetic oil, synthetic fuels. Those are also kind of one way or another hydrogen involved, hydrogen based, but that addition, as you can see in 2050 in that last column. So the point is, with all the hype about the hydrogen, it's still not going to provide the solution, even if it's going to work. And, well, the economics is not really there. So that's another diagram which shows that if you want to decarbonize, we have to pay the price, because that's more expensive. And again, the options of unabated versus options with carbon capture versus options with hydrogen, you can see that the costs are getting higher and higher. And I would say even these costs probably optimistic. And so we're not really sure how that is going to evolve and how that is going to work. Well, since at least in our part of the world, I got questions about hydrogen every day and probably several times a day. And well, just to illustrate that there is a lot of different flavors of hydrogen, different colors of hydrogen. And whenever we speak to policymakers, at least whenever I speak to policymakers and industry in Germany, if you say hydrogen, and if you forgot to say green hydrogen, then they immediately lose any interest. So, well, hopefully that's not really the story here in Spain. There are many other ways how to get to hydrogen in a much more economically efficient way. And again, we need to be still very careful about the current hype versus the reality. And kind of why IEA is very optimistic about hydrogen. Well, you can take a look at their projections in terms of the cost of electrolyzers, which are needed to produce the green hydrogen. And the one which you should be paying most attention is that PEM electrolyzer, proton exchange membrane electrolyzer, because those are the electrolyzers which are suitable for green hydrogen, because they can rub up and down. So alkaline mostly are doing the steady production. So we're really looking at the PEM electrolyzers. Well, the story with PEM electrolyzers, we need a catalyst, and that catalyst is iridium, and that's kind of expensive. And more than that, most of that is just in one geography. And we're already learning from recent geopolitical changes that, well, it's dangerous to rely on any particular geography for critical materials. And the situation is not only about hydrogen. If you're going to take a look at the amount of the materials in a typical electric car, you see that in terms of the minerals, you have to have 6 times more minerals for every car, comparable car in comparison to conventional car. But it's not only about cars. It's also about wind, about solar, about all these advanced low-carbon technologies. So we are moving away from fossil fuels, and we are getting to those critical minerals. And why that is important? Well, again, that is going to create opportunity for some of you. So that shows you where to work, where to spend. Well, if you have spare a couple billions of dollars, well, you'd better go and get a mine somewhere in South Africa to mine iridium. But if you don't, well, it's already a lot of money from some parts of the world which are there, and you see that concentration is much higher than in oil and natural gas markets. And this is where things are extracted. If you are going to take a look where things are processed, it's mostly China. Well, again, you are putting a lot of eggs into one basket. Well, that's again the geopolitical story, geopolitical implications of the decarbonization, that actually all these solutions, we need to take a look at the whole supply chains when we are trying to understand what would be the implications of that. So for minerals for clean energy transition, so you have to be really watching what is needed, what are the prices, and what are the chemistries. We know more or less the demands. We don't really know the supplies. Whenever we talk to the mining companies, they say, no, it takes 5, 7, 10 years to develop a new mine. So don't expect that we will be able to ramp up production as quickly as in your projections. And so that's something to watch again. So the summary, I have started with that diagram, and then so hopefully I have persuaded you that even though it's going to be challenging to eliminate all those emissions, where you have challenges, that is going to create opportunities. So I'm not going to provide you all the answers, but at least some of the thinking about different dimensions, that it's not only about the economics or technology, it's also about geopolitics, it's also about environmental implications, recycling of materials, access to different things. And so if one would ask me how the future of energy is going to look like, I will say something like that. But I don't know when, and I don't know at what cost. But we'd better be in that future. So thank you very much.